Hello everyone! In this video, we're going to look at how you'd go about taking the integral of secant cubed x dx. Okay, well I look at that and I say, well, I know the integral of secant squared, right? That's just tangent, right? Because the integral of, or the derivative, I should say, the derivative of tangent is secant squared. So that implies that the integral of secant squared is tangent. Okay, but what about the integral of secant cubed? Well, I could write this. I could write the integral of secant squared x and then times secant x dx, right? I'll admit I really didn't do anything there. I just split it up and now I have secant squared x times secant, but that's still just secant cubed. Okay, but what do I have now? I have the product of two things, right? I have secant squared times secant. So there's a product right here. And whenever you're taking an integral and you have a product inside of it, so you're multiplying two things inside of your integral, if you can't do an easy substitution, a really good technique to look at is integration by parts. So what is integration by parts? Well, it's basically just a formula. And here it is. It says the integral of u dv equals u times v. So uv minus this new integral of v du. Okay, so what the heck does that mean? Well, it means if you've got this integral here, and you can let one thing be u, and then everything else be dv, right? Then you have u times dv, well then that integral will be equal, it'll be the same thing as this, as uv minus this new integral. So whenever I have something that I'm taking the product and I'm going to try to use integration by parts, I always want to set it up pretty much the same way, where I'll have u and then I'll have dv, but I'll put dv down here, right? Like across on this diagonal axis away from u. Now why I do that? Well, because you've got u and you've got dv, right? But then what else do you need for this formula? You've got u, you've got dv, well you still need v and you need a du, right? And then you have all the parts and you can plug it into this formula. So we have u, we have dv, we need du and v. So if we have u, now what do we want to let u be? Well, we want to get du, we're going to differentiate, we're going to take the derivative of u. And to get v, if we have dv, we want to take the integral of dv to get v. So whatever you let u be, you better be able to take the integral of whatever is left, because whatever is left is going to be dv. So if we let u here be secant x, and then dv is forced to be whatever's left. So if u is secant, then dv has to be secant squared x dx, right? It's everything that's left inside your integral, including the dx, everything that's in there. Okay, so now we have our u, we have our dv. So how do we get du? We just differentiate secant. And derivative of secant is just something you pretty much memorize. It's secant x times tangent x. Okay? And the last thing we need is our v. Well, we have dv, so we're going to integrate. If we integrate this, then we go backwards. That's why I put it down here. We go backwards and we get v. And the integral of secant squared x with respect to x is just tangent x, right? Because now if you have v, take the derivative of v, what do you get? Derivative of tangent is secant squared. So there's all our pieces. Now, what this formula says, it says that the integral of u dv, so it's going to be this axis, the integral of u times dv, and that's everything we have. It's secant x times secant squared x dx. That was our original integral. That is always going to equal u times v. So it's uv, which is secant x times tangent x, secant x tangent x, and then it's minus the new integral. And the new integral, if the first integral was this axis, the new integral is always going to be the opposite diagonal, the opposite axis, right? So this was where we started. The new integral is always this axis. So it's tangent x times secant x tangent x, and that gives us secant x tangent squared x. So it's minus the integral of secant x tangent squared x. And then, yeah, dx. I forgot, you should always have the dx here. If you integrate secant, you get secant x tangent x, but that is with respect to x. So we have a dx, so make sure we have a dx on our integral. Okay. Now, well, I see one other thing I can maybe do to possibly simplify this a little bit. I look inside here, and I see the integral of secant x tangent squared x. But how can tangent squared x be written? Well, I think back to my trig identities, and I only memorize one trig identity. The only one I memorize is sine squared x plus cosine squared x is equal to 1, right? That's always true. And that's the only thing I memorize. I don't memorize what tangent squared x is, what secant squared is. That's too much to memorize. I have no idea what that is, but I can always derive any of that from this equation. So I want to know what tangent squared x is. Well, I know sine over cosine is tangent, so I can divide everything here by cosine squared. And I get tangent squared x, that is sine squared over cosine squared, plus, I'm dividing everything by cosine squared, so this is going to become 1, right? Cosine squared x over cosine squared x is plus 1 equals 1 over cosine squared. 1 over cosine is secant, so that's secant squared x. And if I don't know what tangent squared x is, well, I just can subtract the 1 and get tangent squared x is equal to secant squared x minus 1. Okay? So I can then plug that in for my tangent squared and get, so this is equal, this is the integral of secant cubed x is equal to all this, which is secant x tangent x minus this integral, so minus the integral of secant x, but then tangent squared x is just secant squared x minus 1. So my times tangent squared, which is secant squared x minus 1 dx. All right? Well, I can distribute that, and what will I get? I can distribute that secant. We still have a secant x tangent x out here. Oh, and I'm almost running out of time, so I'm just going to leave it right here and be back really soon in another video where we're going to finish up. See you really soon.